Hi everyone, welcome to you all in another session of AI/ML. As you remember, in the last session, we have completed till the regression part, like the linear regression part, how we have to do the calculations, what are the evaluation matrices, and eventually how we have moved ahead. Like the coding part also we have discussed of, right? So now we will be just considering up with the classification part because this topic is basically considering under the supervised learning parts. So under supervised, we have two major criteria, that is the linear one, that is the regression basically, and the classification. Okay. The regression part we have already covered. So in today's session, we will be covering the classification part in details. And after that, we will be just moving down to the unsupervised section. Okay. So let's just complete the supervised in today's session. So let's just share my screen up. Yeah. Hopefully, my screen is visible to you people. So, the very first thing that we need to discuss here is classification. Okay. So, we will be going from the absolute scratch portion so that things can be easily understandable to you. Okay. So, what is classification? Classification means putting things into group based on what they are. Okay. Let's just take some examples so that you can get an idea. Now, suppose you have to sort the toys. Okay. So you have soft toy category, you have cars, you have balls. Also, if you need to sort the fruits, so there are different kind of fruits, right? So you have to sort it based on the kind of fruits being apple, banana, orange, like that. Okay. So you look at each of the item and decide in which group it should belong, right? That that is the decision making process. So that is actually the classification that you are doing. Okay, now let's just talk about classification in case of AI and ML. In case of machine learning, classification means like teaching a model to decide which group which group something belongs to. Okay, in which group something is actually belong to. Now my model does not exactly what humans do, but use the data and the rules. So this my model exactly like in the same way what humans actually do. The my model is also doing the same, the classification, but for that it uses the data and the rules accordingly. Okay. So now let's just go on and understand it in a bit detail. So classification is when my model learns how to say that this item belongs to group A and this item belongs to group B. Okay, let's just take an example. So the school bag example we can take. So imagine you have a school bag. So heavier bag goes to class A and lighter bag goes down to class B. Okay, so you check the bag and classify it based on like bag weight, like let's take it as bag weight, and we take it as class. So based on it, if it is heavier, then we are going down for class A, and if it is light, then it is moving down to class B. Okay. So that is the case. So this is what we are doing. This is actually classification, like classifying the bags based on the characteristics of the weight that in which class it will belong. Okay. So the important word here is class. So what is class actually? Class is simply a group name that we are like referring to. So in some of the real-time example, if we need to just discuss and understand, that will come with the email. Email, like the email can be spam, non-spam email. Animals, animal can be dog or a cat. Like student result, the student has passed or failed. Weather can be sunny, can be rainy, can be cloudy. So each possible answer is called a class here in case of classification. Okay. Now coming down to the type of classification. So we will be first discuss about types of classification. The very first one is binary classification. So what is this binary classification? Binary classification is two group classification. Okay. So binary is equal to two, right? So the examples for this would be like yes or no, true or false, pass or fail, spam or not spam. So only two class is available. So this is a type of classification that is binary classification. We will be discussing about it in details. Don't worry on that. But just as of now, we will be enlisting the types of classification and then equally will move ahead. Okay. Next, we have the multi-class classification. We have the multi-class classification that is more than two groups. So, for example, the fruits are apple, banana, orange, and the grades are like suppose A, B, C, D. Traffic lights are red, yellow, green. Also, we have like the weather. What is it? It is like sunny, rainy, cloudy. So this is a multi-class classification. That is, the class is having we are having more than two classes. Okay, so that has come under multi-class classification. Now, how does the model learn about this classification? That is the part that we need to discuss. Okay, so my model learns by looking at the example just like a child actually do. Okay, now suppose for an example, let's take an example here. Now, in case of example, if we need to consider, first would be animal. Animal. Next, it would be like it has fur. Maybe it says meow, and we have the class. Okay, yeah. Now, if we are calling the name as cat, then in case has fur, we will be writing yes, says meow, yes, and class would be cat, right? Now, here about animal, we are calling it as dog. Now, here far, yes, say meow, no, and it is a dog class. Again, we are taking it another cat class. Cat, we are taking yes, we are taking yes, we are taking it as cat. Okay. Now, after seeing many examples, the child learns that if it says meow, then it is coming down as a cat class. The model will learn in the same way. You can understand the pattern here. For all of the animals, as far as of course, yes, but says meow, that is different. If the same kind of data is repeating for cat and dog animal, so here you can see for dog it is yes for far. For meow it is no, but it is coming down to cat to dog class. Sorry, coming down to cat. If it is has for yes, if it is says meow yes, then it is coming down to cat class. Again cat with for yes, meow yes, and it is coming down in cat class. So you can see after seeing all of this example, my model will able to understand if it says meow, then it will come under the cat class. Okay. Now coming down here about data. So what is this data? Data is, as I already mentioned, as the information. Information like here you can see about far, the person like the animal has far or not. That is an information. The animal says meow or not. That is an information. Similarly, about humans, we can think it is about age, height, color, weight, uh, what is the marks they have got. So basically, my model will learn from the data. So model needs the data to learn the pattern, and based on the pattern, they can do the classification accordingly. Now coming down to features. What are features? Features are the details that is used to make the decision. Okay, so let's just take it of features, because if you are not writing, I guess you people might get confused. So the term is features. So features is like it is, as I mentioned, it is just like the details that we are using to make decision. Okay. So suppose we have got the features like the fruit we have. Okay. Now suppose we have the features as color. Next we have the feature as shape. Next, we have the feature as taste, like this. And coming down about the meaning. What is the meaning that we are taking up here? So the color might be red or yellow. About the shape, it can be round or long. Coming down here about the taste, it might taste sweet or sour, any one of them, right? So my model look at the feature to decide the class accordingly. Now coming down to any one of the examples. Okay. Now I want to get the student result classification accordingly. Fine. So my goal is to decide is the student passed or failed. The features that I am taking, that is the marks of the student and the attendance. Okay. So now here if I am taking the marks and attendance, and I have the result. Okay. So now let's take about the marks being 80, attendance high, and then the result is pass. Coming down here, the marks is suppose 35, the attendance is low, and the result is fail. Coming down here, the marks is 60, the attendance is high, and the result is pass. Okay, now this is my data actually, and I just need to just format it so that it can be visually like looking good. Now here we can say this result. This result is the class. So it has two specific classes. This is the binary classification that we are going here. So the result here we can say that is either pass or fail, right? So the important word is coming out here is the labels. So this is the labels. The labels are the correct answers. Like what are the correct answers that we are getting here. So this we are calling it this class. This class are basically nothing but the result. So for example, input here, what are the input that we are giving? Input is the student marks and the attendance, and in return, the output that I am getting is the student passed or failed. So this output is actually my labels. So labels actually teaches the computer what is the right answer. Okay, so that is the label basically. Now, supervised classification, we have to understand about supervised classification. So, what does this supervised mean? We already discussed about it. Just to have a recap of everything, we are just doing that. So, what does supervised mean? Supervised means like there is a instructor or monitor who is present. So, the computer is showing with like basically not the computer, the model basically the model is shown with the question, that is my data, and the correct answer, that is the label, right? So just like we are doing down in the school days and the like when we are young, when we are doing that, so teachers gives us question plus answer, and we being the student learn it, and based on that, the most classification problems are tackled. So this most classification problem that we will be discussing, that is coming under the supervised one. Okay, let's just take an example about email spam detection. Okay, so what is my goal? My goal is to decide it is spam or not spam. Okay, so basically, what features I can consider: the words used. Coming down, I can use the number of links. I can use the sender details, like who is the sender, that details I can take. Now, basically, suppose I have the email text that is coming as win money now. Okay, my text is coming out as win money now. Okay, now the link, if I am calling about link, so link is suppose many links are there. In that case, I will be calling it as a spam, right? And the class here, I am calling it as class. And now, suppose in the second one, we have got an email that is meeting at 10 a.m. Okay, so here there is no link, and we have got the class as non-spam. Okay, so this is how we are taking it, because my model actually learns the pattern, and based on that, it actually gives us the prediction or the result. Okay, coming down here as the prediction. What is prediction? So after learning, the model or computer, whatever you say, that can predict the details, right? So for example, new email has arrived. The computer actually, or my model actually predicts like this looks like spam. Okay, so this is called the classification prediction, right? Now, what happens if the model is wrong, right? Sometimes the model makes a mistake, just like humans, right? So here also my model also can make a mistake. In that case, what happens? The model says, like suppose I have a spam mail, but my system or my model actually says it that it is spam. Okay, then how we need to tackle it? We need to get with the accuracy. Accuracy means how good is the model. Accuracy means how good my model is actually good and how good it is performing based on that. Okay, so how many answers are correct based on that, the accuracy is getting, it gets actually decided. Okay, now coming down, suppose for an example, I have got 100 emails, and among them 90, sorry, here the spelling is wrong. Yeah. And among it, 90 predictions were correct by the model, right? So I'll be telling that the accuracy is around 90%. The accuracy that I am getting, that is 90%. Okay, so this is about accuracy. So we will be discussing about some of the common algorithms, the common algorithms that we have to discuss about classification, that is decision tree. That is like asking question. We are just asking question, and in the tree-wise format, it will be going. Next is K nearest neighbor, logistic regression. All of this we will be discussing one by one. Okay. Now, if I need to understand where this classification based models are used in real life, so we can discuss about the disease detection, face recognition, email spam detection, product recommendation, student result prediction. All of this is coming under classification. Okay. Now we have to just take it accordingly because we have initially understood about the types of classification being the binary classification and the multi-class classification. So now we need to have a closer identity and idea about how they are and how they actually work. Okay, binary versus multi-class classification. So we need to explain with it accordingly. So first, there like we need to understand about the classificational details, like as we already discussed about a binary. So binary is just like having two different classes. Okay, binary means two, right? So two different classes we will be getting like on, off, yes, no, true, false. So binary classification is like only two groups. Okay, so here, being the rule, like imagine suppose a school gate with a guard. Okay. Now, if the student has ID card, then the student is allowed inside the school. If the student has no ID card, then the student is stopped there. Okay. So it has two specific groups: allowed, not allowed. So that is that's it, right? You can just get two different decisions, so this is the binary classification. Okay. Now, for example, like has ID card? Yes, then it will be allowed. Has ID card? If that is no, then not allowed. Right? That needs to be checked. Now, coming down about the email letters. Email letters, like the model actually checks the emails. The question is like, is the spam mail? Like, is the spam mail? Like this kind of question I am having. So based on that, I am having two results like spam or not spam. Or if I have the question like, is this email spam? So I will be having two answers, that is spam or not spam. There is no third option. So that is why it is a binary classification. Coming down about exam result, right? The model actually checks the marks. So if the marks is greater than 40, then the person or student is passed. If the marks is less than 40, then the person is failed. Sorry, if the person is failed. So we have two different groups out here, passed and failed. Again, we have another binary classification that we have discussed up here. Okay. Now, the most important thing to remember here in case of binary classification, that is only two groups would be there, and the decision making is quite easy, but mostly yes or no type of problem we will be getting. So we need to understand it, and based on that, we need to tackle it. Okay, coming down to multi-class classification. Okay, so multi-class classification is like more than two choices we will be having on. Okay, so multi means many. So many class classification, that is more than two groups. So suppose we have got to an ice cream shop, and we have got an ice cream like the flavors of ice cream about chocolate, strawberry, vanilla, then mango, all of it. So the model job is which flavor did that child like, or did that child choose? Like, will that child choose basically? So there are more than two options. So it is a multi-class classification. Okay. So for example, we have the color, taste, and the ice cream. So, of course, the flavors of the ice cream to be very specific. If suppose the color is brown, and we have the taste, of course, it would be sweet, and it is the flavor is chocolate. And coming down here, we have suppose it's pink, it's sweet, of course, and we have it is like strawberry. Now we have suppose white, of course, sweet, and it is vanilla. Okay, so this is an example of multi-class classification because we have more than two choices. So of course, when we will be dealing with this kind of classification problem, my model would need way too much like data to learn. Actually, in the training phase, my model will need a lot of data to get the training accordingly, so that it can predict the result accurately, and we will be getting the exact classification. There shouldn't be any misclassification. To avoid any of the misclassification, we need to train our model with a lot of like huge data, right? Based on the number of groups or categories we are having. Here is three. If we are considering more, around suppose 50 groups are there. In that case, my data needs to be huge. Okay, coming down about traffic lights. There are three possibilities: red to stop, yellow to ready, and green to go. So, three groups that is coming under multi-class classification. Animal zoo, right? The model sees the animals. There are many animals like different birds, elephant, crocodile, like the alligator or crocodile, coming down to any of the like blue, Nile guy, or anything like zebra, giraffe. There are many options, right? So more than two animal types we are getting up here. So that is coming under multi-class classification. Now about student grades. So model checks the grade of the student. There are many options like A plus, B plus, C plus, D plus, and F, right? All of this. So many classes are there. So multi-class classification. Okay, so the key difference between binary and multi-class is binary is containing two groups and multi-class is more than two groups. Binary is generally having like yes, no, pass, fail, spam, not spam, this kind of examples we are getting. But in case of multi-class, we have got many choices like the flavors of ice cream, like different grades, different animal type. So this is about the two types of classification. Now, how does a model decide? So, model looks at the features, and based on the feature, then it decides that this fruit belongs to which group, or this ice cream belongs to which flavor. Just by looking the color and the texture, all of these features basically. Okay. Now coming down to one prediction example. Suppose we have taken, like we have got a the example of fruit, right? We have already taken an example like that. Yes, we can take this. Okay, fine. So we have taken the features as color, shape, and taste. Okay. Now, based on it, suppose we have got a new fruit, and the fruit, like the color of the fruit, like based on these features, we have to decide. So now, suppose the color of the fruit is yellow, and the shape is long, and suppose the taste is sweet. So based on these features, we will be just taking it, and the model will say that this is the fruit is banana. Okay, so that is a multi-class prediction that we have done. So now, can this model also make a mistake? Of course, yes, it can make a mistake. Example, suppose the model says it cat, but actually that is a dog. So this is a misclassification or wrong classification that has happened. Again, to tackle it, we need to just understand about the accuracy that this model is having. Okay. Now, how often the model is correct, that needs to be taken care by the accuracy. Suppose I have done the predictions on the data, and I have about suppose 10 questions I have. Okay. So the 10 questions I have, and based on the 10 questions, 8 are correct. So I have got 80% accuracy on my model. Okay. So binary classification is two choices. Multi-class classification is many choices. So model uses the examples to run to learn actually in the training phase, and then model predicts the correct group or the classification, classify it accordingly based on the learning that it has taken in the training phase. And after that, we have to also check if our model, like what is the accuracy of my model. So for because my model can do any of the wrong prediction or misclassification can be done. So just for that, I just need to get a confirmation that how much accuracy my model is having. So what is accuracy? Based on suppose 10 questions, my model is able to answer 8 questions. So that is 80% of accuracy that we can think about. Okay. Now, there are other parameters as well by which we can decide and understand about it. Okay. So we'll just discuss that. Okay, just a moment. Yeah, fine. So first we will be discussing about errors. So we have already done that just to have a recap of it. So we'll just have a smaller, a little discussion about it so that about when we will be discussing about the error matrix or evaluation matrix basically, we will be getting to understand each of them in detail. Error is what the model when the model is going wrong. uh, Error is like when the model is going wrong. So just like about suppose this in the school, so you answer a question that has been asked in the school or college, anyone you can think of. Now about your answering this question, that is correct, but the when you are answering it wrong, right? The same thing happens with the model, right? So, suppose there is an ice cream prediction that is going on. Imagine that the model tries to guess the ice cream flavor that you will be choosing. Okay. So, suppose your choice is chocolate, the model guesses chocolate. So, of course, there is no error. So, your choice was vanilla, but the model actually chose around the ice cream flavor being strawberry. So, there is an error there. So, the model couldn't just understood it and accurately predicted. So there is a misclassification that has happened. So that is an error. Again, if you are going ahead about choosing about like suppose you are choosing again vanilla and the model also gets it vanilla. So there is no error. That is correct, right? So whenever the model guesses wrong, it is called an error. Whenever it guesses it right, it is correct. Okay. So whenever the model guesses it wrong, it is error, as I mentioned. Now here becomes the concept of accuracy. Okay, so accuracy is when often, like it's like how often the model is actually giving is a correct result. Okay, so there is a formula to find it. So number of correct guesses, okay, number of correct guesses divided by total number of guesses, that would be total. That would be multiplied with 100. Okay. So now suppose here we are taking an example of suppose school test. Okay. Yeah. Now we'll take an example of school test. Suppose we have questions. Next we have answer and we have the correct. Is it correct or not? Okay. So this is my part. So now here suppose question one answered is correct and my prediction was also correct. Okay. My question is two. I have the answer is wrong and the correct. Is it correct? So it is wrong basically. Now coming down here, we have got correct, like my question based on three. The answer is what the answer my model is giving. That is correct, like C. and we are correct or incorrect. That is correct. Coming down to 4. So if it is 4, it is correct and it is correct as well. 5, correct, correct. Now 6, the answer is wrong. So it is wrong. Now it's 7. So we'll take it as 7, 8, 9, 10. And we'll take it all correct. Yes, we'll just stretch it like that. So we will be just getting it like that. So here we can see that we have got a total correct answer out of this, like the correct and correct like this. We are getting the total answer, total question is 10. The correct within it is 8 and number of wrong is like correct would be 8, wrong would be 2, and based on that, my accuracy would be 80% because I will be doing 80 divided by 10 into 100. So that will give me as 80%. So this is my accuracy. Okay. Now suppose I am going for an animal guessing model. Okay. So suppose we have the picture. Next we have the model guess. Next we have the actual. Okay. And then we have the, is it correct or not? Suppose picture 1, model guesses cat. It is actually a cat. So like it is correct. Like yes, it is correct. Now coming down here to 2, it is dog. And actually it was actually the picture of a dog. Of course, it is correct. Now coming down to 3. So suppose it is a picture of a cat, but it has been given as dog. My model predicted is at like my model predicted it as cat. The actual was dog and it was wrong. Like no. Coming down to 4. So we have it is a rabbit. So my model also predicted is at a rabbit and it would be correct. The fifth one would be again a dog. The model guesses as dog, but it was a cat and it was a wrong prediction. So there is an error. Okay, so let's just change it with E, that means error. Okay, so now what happens? The total number of picture here is 5 and the correct among it is number of Y, that is 1, 2, 3. So that is correct, that is 3, and error, that is 2, of course. Now the accuracy that we need to discuss. So accuracy would be 3 divided by 5 into 100. Okay, so that will be giving us as 60%. Okay, so for this model, the accuracy that is coming, that is 60%. So error is the wrong one. Accuracy is like how many times did the model get it correct. Okay, so this is about this. Now we will be going down with the another evaluation matrix, that is precision. Okay, precision. So precision is like we need to find out and understand about this part accordingly. So precision is like of all of the time model said yes, how many times it has correctly said yes. Okay, so it's like suppose I want to find the candy. Okay, imagine a model is helping you to pick the chocolate from the big box of the candy. Okay. Now the chocolate, the box actually has chocolate and other candies. You specifically want the chocolates, not the candies. Okay. So the model says, like, suppose I found the chocolate here. Okay. That is the output that model is giving. So the question is, out of all of the chocolates it picked, how many were really the chocolate? That's the precision. Okay. Now, for an example, let's take an example on this. Precision is candy picked. Next, we have actual candy, and it is correct or not, right? So, the candy picked, what is the candy picked? It is chocolate. So, majority would be chocolate only because precision is about the yes part only. So, let's take it 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. This one. So this would be all of the candy piece is chocolate. Actually, it was candy. It was a chocolate. Like actually, it is a chocolate. So it is said. Suppose yes. Now for this, suppose it is no. It was a toffee. Now here, suppose it is sorry. It is a chocolate. Sorry, it's a chocolate. Now for suppose it's a lollipop. And again for this, it's a chocolate. Okay. Now about correct, of course, it is a chocolate. The actual was chocolate, so it is yes. Coming down, it is a chocolate, but it's a toffee. My model has taken it as chocolate, but actually it was not a chocolate. It is a toffee, so it's a error. Again about chocolate and chocolate, so it is yes. Again, chocolate with lollipop, there is an error. Again, chocolate and chocolate, then it's yes. That is why. So again, the total yes, that is a chocolate, like the total yes, that is a chocolate, that is picked up, that is 5, and the correct pick is 3, right? So number of yes that we are getting, that is 3. So the precision is 3 by 5 into 100. So that is giving us 60%. So precision is equal to 60. Means that only 60% of the model's yes is chocolate. So it actually guesses where actually the yeses are going. Okay, how yes actually the model is saying how it is taking it accordingly. So that is calculated as precision. So for this, the precision would be 60%. Precision is 60%. Okay. So how we have calculated it? So total number of chocolate, like total number of yes, that is 5. And actual, with comparing with the actual result, where times it is yes, that is 3. So 3 divided by 5 into 100 is giving us the result of precision. Okay. Now coming down to email spam. In case of email spam also, suppose imagine the model says this email is spam. So out of 10 emails it marked as spam, 7 were actually suppose spam and 3 were actually the normal emails, right? So in that case the precision would be 70%. So precision is how carefully the model, how careful the model is when it actually says that it is spam. Okay, so this is the part that we need to understand. Precision is of all of the yes guesses, how many are really yes? And higher precision does mention that model rarely lies when it says yes, and low precision means like the model says yes a lot, but something is wrong up there. We need to recollect over it. Okay. Now coming down difference between accuracy and precision. Accuracy is how often the model is right all over the prediction it is giving. About precision, how often the model is right when it says yes. Okay, so it's like about the accuracy, it's like how many correct out of all guesses. But in case of prediction, in case of precision, it's like how many correct out of yes guesses. Okay, so hopefully you have understood the like what is the major difference that we are getting in case of accuracy and precision, and both are an important criteria that need to be taken accordingly when we will be working with it. Okay, so that needs to be equally handled and easily needs to be understood. Okay, so hopefully guys you have understood all of this section. Next we will be going down with recall. Okay, so we will be going down with recall. So what is exactly recall? Recall is like if I need to just give you an example, recall is about how many of the actual yes item of the model is able to be found. Like suppose recall is of all of the real yes item, how many did the model actually find? Okay, so suppose finding the chocolate. So imagine that this basket contains 10 chocolate that has the like hidden. This five chocolates or 10 chocolates are hidden among the candies. Okay, so the real chocolates were 10. What is the real chocolates? That are 10. The model picks up 7 chocolates. So five are really chocolate and two are not. So recall is equal to how many real chocolate did the model actually pick. Okay, so real is like recall is like real chocolate pick by the total real chocolate into 100. So recall equals to 5 by 10 into 100, that is giving us 50%. So model found 50% of the real chocolate. Okay, hopefully you have got it. Let me just re-give the example again so that you can understand it once more time. So like you can imagine that there is a basket and it contains suppose many candies, and among all of these candies you have only kept 10 chocolates. 10 chocolates like Cadbury, Dairy Milk, like that. That one, 10 of them you have just hidden them inside that basket of candies. Okay, so the real count of the Dairy Milk chocolate that you have bought and that you have hidden in that basket is 10. Right now, when you are just asking your model about the predictions, the model picks like suppose 7 chocolates, and among those 7 chocolates, five are really chocolate and two are not the chocolate, two are candies. Okay, now here come down the recall. Recall is like how many real chocolates did the model actually picked up. So recall is the real chocolate picked by the total real chocolates into 100. So it is giving us like 5 among 7, 5 were real chocolates. So 5 we have taken, and we have taken like the 10 chocolates were there that has been hidden. So 5 by 10 into we are doing 100, right? So that is actually giving us the result like this. So that is actually giving us 5 by 10 into 100, that is giving us around 50%. So the model has a 50% of accuracy. Okay, so coming down to another example so that it becomes easier for you. So email spam, we have already discussed about email spam. So let's discuss it one more time. The spam email. Okay, so spam email is like imagine that is a model checks the email to find is it a spam or not. So total spam email that are there inside your inbox, that is 20. Okay, and the model marks 15 of them as a spam. So actual spam is how many? Actual spam was around 12, and And among this 15, 12 were actual, like model marks 15 as spam basically. And actually, spam is around, suppose 12, and normal was around 3. Okay, so based on that, what happens? So 12 is equal to spam and 3 were normal. Okay, now coming down here about the recall. So what would be the recall value? So R would be equal to total emails of the model that has been caught as a spam, that is 12. That would be divided by 20, the total number of spam email in the inbox. That will be multiplied with 100. So that is giving around 60%. Okay, it would be 100, sorry. So it is giving us the value like this. Okay. So the recall value is 60. So like now you have to answer like about precision and recall. There is an there is a slight difference. So precision is of all the yes guesses, how many are really yes, and recall is for all of the real yes items, how many did the model catch? That is the trick part here. There is a slight difference between the precision and recall. You just need to take it accordingly. Okay. Now suppose let's take a example. Suppose there are 10 hidden treasure in the forest. Okay. And the model finds 7 spot and digs it and accurately let's write it for easy understanding. Like 10 hidden treasure. So among this, model finds 7 spot. Model found 7 spots. Okay. Among the seven, mark it accordingly. Among the seven, five were actually treasure, five were treasure, and 2 spots that are there that was empty. Okay. Now coming down to precision. How careful is the model when it digged? That is what the precision actually gives us. So precision would be 5 divided by 7 and that would be multiplied with 100. That is giving us the result as around 71%. Okay. So that is giving us the result as 71%. This is precision. Okay, now coming down to recall. Recall is how many treasure did the model actually find based on the number of treasure actually were there. So it will be 5 divided by 10 into 100. So it is around 50%. Okay, so this is the recall value. So let's just adjust the same. Yeah. Now you can understand that how the data we are taking in. Okay. Now the major difference between precision and recall is precision is of all yes guesses, how many are correct? Yes guesses by the model. Okay. How many of the all yes guesses, how many were correct? And about coming down to recall of all the real yes items, how many did the model find? That is the major difference. Okay. Now coming down with the confusion matrix. Okay. So confusion matrix. So first you need to identify about what is the confusion matrix. First, what we have known till now, what is the model? Model is a smart guesser that actually guess on behalf of us, uses a training method, and based on that, it gives us the predictions accordingly. Now we have all of this. We have discussed about accuracy, precision, recall. Now we will be just simply diving to the confusion matrix. The confusion matrix is basically a table that shows how many things the model guessed correctly and how many it got wrong. Okay. Now, Now, like suppose this candy guessing game, okay? So now imagine the model guesses candy in a basket. So basket has chocolates, that is five, and it has like suppose lollipops, that is also five. Okay, so equal guesses you can get like the five chocolates, five lollipops, right? Now the model guess we are getting real candy and the model guess. Okay, so real one is suppose chocolate. Okay, so and this is it, and it has also predicted chocolate. Now coming down, suppose it is chocolate, but here it has predicted lollipop. Now coming down here, it is again a chocolate. Now here it has predicted is again a chocolate only. No issues with that. Now suppose here we have got a lollipop, and it has predicted it accordingly lollipop. Okay, what happened? And now here suppose it is a lollipop, but it has predicted a chocolate. Okay. So this is the real candy and it is the model guess. So here chocolate, chocolate. So it is yes. It has predicted correctly. Chocolate lollipop. No, the prediction is wrong. Chocolate, chocolate again. So yes, prediction. The prediction is correct. Actually, lollipop, lollipop. The prediction is correct. Prediction is correct. Lollipop and chocolate. The prediction is wrong. Okay. Now what we will be doing here based on this data, we will be drawing a confusion matrix. So confusion matrix is exactly a two cross two, like two rows, two column basically for the binary classification. Like the two groups we would be having the rows and the column, the real candy and the guess model guess basically. Okay. So how we will be taking it? We will be showing it then. The first one is the real, that is chocolate, and then we have real. We will be having lollipop like this. And here we will be having the model. What is the prediction of the model? So okay, the prediction wise prediction chocolate based on the model. And here we have again model. The model is coming down with lollipop. Okay. Now suppose what are the values would be here that we need to fill. Okay. So we need to fill the table. So real chocolate and the model chocolate. So real chocolate, model chocolate. So correct. How many are correct? So that is coming out as true positive. Okay. Now coming down as real chocolate with model lollipop. Like this position, real chocolate with model lollipop. So this is basically wrong. How many were wrong in that case? That is false negative. And this one, that is real lollipop, model is chocolate. That is wrong. That is false positive. And this one is coming up as true negative. Okay, so that is real lollipop, model lollipop, that is correct. Okay, so that is the true negative. Okay, so here you can see from this idea that is what is what is the idea of this chocolate with chocolate that we are getting here. One chocolate with chocolate, chocolate with chocolate, that is yes, that is two. So here in this place we will be getting the result as 2. Control Z. Okay, let's just copy this. Control C, Control V, and here we will be getting the result as 2. Okay. Now here we have chocolate and lollipop. Chocolate and lollipop, that is false negative. That is that it has not predicted correctly. That we have got 1. So we will be putting it here as 1 like this. Now lollipop with chocolate. Lollipop with chocolate, and it is false positive. So false positive we will be getting 1. So here we will be taking it as like that, and lollipop lollipop, that is a true positive, that we will be getting as 1 here. So this is about it. Okay. So now what is this true positive? The model said yes and it was really yes. Okay. So that is coming about true positive. The model said yes, and like model guesses was chocolate and it was really chocolate. Again, model guesses was chocolate, it was really a chocolate. So we need to see all of this. So chocolate, chocolate, why? Chocolate, chocolate, why? So it is 2. That's why we have got the value as 2. Okay. That is the model guessed it chocolate and it was actually a chocolate. Now coming down true negative. So model said no and it was really no. Okay. So model said no and it was really no. So model guessed lollipop and it was a lollipop. That is true negative. True negative is this one. True negative, this is true positive, this is true negative. So diagonally we are getting true values and diagonally we are taking the false value. So here true positive and true negative, as I mentioned, like the model said no and it was actually no. So the model guessed for lollipop and it was actually lollipop. Like model guessed lollipop, it was actually lollipop. So we will be getting here as no. Like no means we are actually calculating the chocolate. The lollipop was no. That's why. So here you can see lollipop, lollipop, right? So in this position, we will be getting true negative. So it was not a chocolate, it's a lollipop, and actually the model also predicted it as lollipop. So it is true negative. So we are getting the value as 1 here. Okay, you can get it. So now false positive. False positive, like the model said yes, but it was actually no. That is, the model guessed it chocolate, but it was lollipop. Model guessed it chocolate, but it was lollipop. Yes, this one. Model guessed it chocolate, but it was lollipop. So it was N, right? So we have got it one more here. FP. FP means this position. And coming down to false negative, model said no, but it was actually yes. The model guessed it lollipop, but it was chocolate. Okay, so this one. So that's why we are getting the counts here like this. Okay. So this is a confusion matrix. Now we will be again taking the example of spam email because for all we have taken it accurately. So for this also we will be taking. So total spam is suppose 10. Among them, real spam, real spam was 5 and non-real spam was again 5. Okay, non-real spam is also 5, like equal distribution. Now here, the same thing we will be taking real, like along why we will be taking real, that is spam, like first one is spam. Okay, let's take it here. Spam, and this one is not spam. Here also we will be taking spam and not spam. Okay, first draw will go down here and we'll take draw and we'll add this. So this is y. So along this, we will be taking it as the real. And this is the x. So for this, we will be taking for the model, like what is the prediction that model has given. Okay, like this. Okay. Now here again, we have got spam, spam, not spam, not spam. So here we will be taking here as suppose it is like it will be taking it accordingly. So we will be taking it just for a number. So model is real is spam and the model is also saying spam. So it is 4, that is true positive. Now here spam and not spam. So it is false negative. So we are taking as FN, sorry, false negative. This is the position of false positive. So suppose it is 2 false positive, and here suppose we are taking it as 3 and as true negative. Okay. So basically, how to read this confusion matrix? TP is the correct yes. TP would be the correct yes. TN, that is this position. This is like correct no. This is wrong section. So this would be FP. FP is wrong yes. And this is wrong no. Okay. So now we need to calculate the accuracy, precision, recall from the confusion matrix. So how we will be doing that? So we will be taking for this. Okay, just for a reference, Control Z. Okay, we can take the accuracy up here so that it can be taken accurately. Accuracy, we will be calculating here from it, from this confusion matrix we will be taking. So TP plus TN we will be doing by all, like TP plus TN plus FP plus FN. Okay, all of it. So for this example, what we have taken 4, 1, 2, 3, 4, 5, 6, 7, 7 plus 3, 10. So all of this we have to take. So 4, 2 positive, 2 negative, that is 4, and 3, that is 7. 7 by 10, we will be doing here, 7 divided by 10. So that is giving us 70%. Right? So coming down to precision. Precision, because that would be true positive divided by true positive plus false positive. Okay, so that is actually here you can see what is true positive. True positive is 4, and coming down to for like true positive plus false positive, that is true positive 4 and false positive is 2. So 4 plus 2, that is 6, that is 4 divided by 6. That is 4 divided by 6, that is giving us around 66.7%. Okay, now coming down to recall, that would be TP divided by TP plus FN. Okay, so TP is actually 4. TP is of course 4, and it would be divided by 4 plus 2. 4 is TP again, and FN is 2, and we will be getting here also. Okay, FN, let's check once. What is the FN? FN is 1, sorry, it is not 2, it is 1. So it is 1. So it would be 4 divided by 5, that it will become around 80%. Okay, so this is how we need to calculate. TP is like the picked chocolate correctly. TN is ignored lollipop correctly. FP is picked chocolate thinking it was a like pick. FP is basically picked lollipop thinking it was a chocolate, and FN is like missed chocolate thinking that it was a lollipop. Okay, so this is the confusion matrix. So from confusion matrix we can calculate all of it, like accuracy, precision, recall, everything we can calculate using this confusion matrix. Okay, so we have discussed all of this part in details. Hopefully, you have understood what is classification, what are this sections in classification, and also hopefully you have understood like what like how we need to just calculate each of the steps in detail. So everything has been discussed. So in the next session, we will be going deep inside and understanding about how we just need to just go with a different models. There are different models related to classifications that we will be checking on, and then we will moving down to the coding section. Okay. So thank you everyone for joining today's session. We will be connecting in the next session again, and from there we will be carrying it over. Okay. So thank you everyone. Bye.